Well, good afternoon. It's great to be here in Las Cruces. It's a very exciting time for the commercial crew program. We'll tell you a little bit about what's happening. And, it's been a busy year since we were here just 12 months ago. Of course, our vision for human spaceflight is to have this vibrant low Earth orbit industry where we have this vibrant enterprise. And, we're about to make that happen very soon within the next 6 to 8 months. We're starting to put our crews in orbit for the space station and also to have those increment missions for the space station. Of course, our goal, we're probably one of the most unique NASA programs, and it's a lot of fun working in this program because we have two purposes. Really, we have a public purpose, and we also have a government or NASA-driven purpose. Of course, we have a need to get our crews to the space station. We'll start flying 4 people and powered payloads very soon. So that's the NASA purpose, to really fulfill this space station mission, which we've been working on since we let the contracts back in September 2014. And then we have the public purpose, which is really to seed this industry and to start having all these missions fly into LEO and to the space station. Of course, our approach hasn't really changed. It's this unique approach that we've started, and as you've seen the lunar program and Gateway starting to pick up this approach where we have defined goals, and for us it's really this 210-day mission to the space station, 4 crew, and about 100 kilograms of cargo. We've defined our requirements, and we're about to see how those requirements are working out in terms of the uncrewed missions and the crewed test flights. We have our firm fixed price contracts, and then just a milestone-based payment approach. And I'll talk a little bit about where we're at with the milestones and how things are going relative to the industry. It's a very collaborative endeavor, and what I would say is we are making a tremendous amount of progress. And if I just look at what's happened over the last 12 months since we were here last, you can really see the teams come together between both NASA and SpaceX, NASA and Boeing. As we get closer to the test flights, you really see the team come together. Of course, we've got a partnership with the FAA, the DoD, the Department of Defense. The Attachment 3 is responsible for crew rescue, and we've been doing a lot of activities with the DoD to get ready to do the rescue function, which the government is responsible for these missions. We've been working with the FCC and the NTIA in terms of the spectrum management. These vehicles are using the Tracking and Data Relay satellite system, and we've been working hand in hand with the industry and also the FCC and NTIA, and then the NTSB. And so there's just a very collaborative group of industry and government working together to make these missions happen. Progress, so you see a lot of these are the milestones that, the upper part is the SpaceX milestones, and the lower blue part of the chart is the milestones for Boeing. And you can see we've checked off a large number of milestones as we're getting down to the final things. And we're really, on the SpaceX side, we have some parachute testing milestones ahead of us. I'll talk a little bit about the Demo 1 uncrewed mission that we flew back in March. Benji was here yesterday and talked about that. And then we're really down to the final missions, which is for SpaceX, their crewed test flight, and then also their in-flight abort test. And then we'll get on to the certification of that system. And so, the blocks look pretty small on the chart, but if you look at the endeavor we're trying to do and the magnitude of the task, we're now at the very challenging part of getting these vehicles certified and across the finish line. Same thing for Boeing. We have a few parachute tests left to do. John Mulholland is going to talk a little bit more about where they're at relative to processing of the vehicles for both their orbit flight test in December and then also for their crewed flight test mission. And then we have a very important pad abort test as well for Boeing. So we're making a lot of progress, and then we'll get into the certification activity and be ready for those increment missions for station next year in 2020. So today where we're at, we have 10 missions in flow. And if you just look at this time frame that we're in, I'll do them in chronological order. So for Boeing, John will talk more about it, but on the range here at White Sands to do a pad abort test in November, early November, November 4th, which is a very important test leading into the orbit flight test. And as John talked, he's on the range for the 17th of December, and he'll talk about the vehicles getting ready. And then the crewed flight test, in the next first quarter of 2020. And then for SpaceX, we have an equally challenging flow of the in-flight abort test. This is a very aggressive test of launching a rocket off of pad 39A, and the rocket will separate the capsule, and the capsule will fly away with its 8 Super Draco engines, and then deploy the parachutes and land in the Atlantic Ocean. And we'll have a recovery operation after that, and we'll also have Detachment 3 on hand for practicing what they would need to do if there were a rescue. And then after that, we'll move into the post-certification next year and start flying regular missions to station with 4 crew for those long 6-month increments with cargo. So we're very excited about that. If you just look at where we're at, the launch pads for both Boeing and SpaceX are just about ready for those crewed flights. If I look at the mission control centers at both Hawthorne and in Houston, where the Boeing Mission Control Center is, those control centers are ready. We're in the middle of doing simulations. We actually do joint simulations between NASA, Boeing, NASA, and SpaceX for what is the equivalent to what people would know in shuttle as the mission management team. We've been doing those practices. And then the Air Force, the Eastern Range, the DoD, the FAA, NTSB is all ready to go, and the agreements are all in place. If I look at the providers, both Boeing and SpaceX are doing an incredible job. It's a tough mission that NASA has given both Boeing and SpaceX to get the vehicles put together and to launch our crews, and also to have an abort system that's active from the pad all the way through the entire ascent time frame. Doing an incredible job of that. There's lots of final testing and preparation of the vehicles underway, and simulations with the team. Just talk a little bit about some recent activities with Boeing, their crew for the CFT flight. Nicole Mann, Chris Ferguson, and Michael Fink are out, been training. This is a training exercise where this was out here at White Sands. It was a landing exercise. You can see in the upper right, coming out of the medical facility. It's part of the exercise. You can see the capsule and the team around them, and then doing training in terms of if the crew were injured. So that's been going on. And then on the SpaceX side, this is SpaceX crew training. There's 2 different activities going on in the upper left. You can see their recovery ship, which they've used successfully to recover the Demo 1 test flight. They'll also use that to recover the crew. So we did a big exercise about a month ago to make sure that all the medical facilities on the ship were ready. We had the flight docs there. We had the crew there, Bob Benkin and Doug Hurley. We went through an end-to-end exercise of how to test that capability. We actually had helicopters involved and flew rehearsal missions to local hospitals in the event we needed that. And then on the right-hand side, you could see some recent SpaceX crew training at the launch pad where Doug and Bob were in their suits and went through some deluge training. And then on the lower left, you can see the pad egress system for the pad at 39A. Our outlook is bright. We have a wonderful partnership between Boeing and NASA, and also SpaceX and NASA. What I've seen as we worked through the Demo 1 mission back in March, that joint team came together in a phenomenal fashion. We've been working hand in hand with John and his team as we get closer and closer to the orbit flight test, and I can really see our team starting to come together. It takes a big endeavor to pull these missions off, and we're ready to start flying people to space next year. And we have a video which we'll show next. now I'll turn it over to my esteemed colleague, John Mulholland.
Hey, thanks, Steve. Pat, hey, thanks for letting us bring this thing home. So we're having a lot of, and thank you guys for your perseverance. My over-under was 15, and so you guys blew that out of the water. So thank you guys very much. And I'll wait for my charts. All right, here we go. Again, thank you guys very much. Pleasure to talk to you again today.
We're not ending the journey today, Mike. We're completing a chapter of a journey that will never end. The thousands of men and women who gave their hearts, souls, and their lives for the cause of exploration. Let's light this fire one more time to witness this great nation at its best.
Hey, thank you. And hey, as we did yesterday, I'll go at pace. I need some feedback on this chart format because I have to take Dramamine before I watch it because there's too much going on. But hey, pretty complex from a mission standpoint when you look at all the facets of it. So from a launch perspective, we build a spacecraft in Florida. We'll launch it in Florida. Normally target a flight day one rendezvous. So we'll dock with the ISS within 24 hours. Obviously, a nominal mission would be 6 months because you got to stay up there as a rescue ship. When it's time to come home, we'll undock, do system checkouts. So within 2 hours after we undock, we should be down on the ground. Only domestic spacecraft ever been built that will nominally land on land to allow reusability. It's pretty interesting. From the deorbit burn to landing, it's only about 40 minutes. So you're coming down pretty hard and fast. As I mentioned yesterday, we are really close. So if you look at at all of the hardware getting ready for orbital space flights, the launch vehicles, the hardware for the uncrewed and the crewed flight test has been completed. It is in Florida waiting for us to deliver a spacecraft. From the uncrewed test flight that I mentioned yesterday, we have scheduled for December 17th on the range. That spacecraft is near built. The only two pieces that are remaining to go on, the forward heat shield, which should be mated tomorrow, and then the ascent cover will go on right after that. As soon as we finish with that, we'll mate the crew module to the service module. Service module is completed and waiting for the crew module build to be completed. We'll do that, do one final vehicle checkout, load it with propellant, and then take it over to LC-41 where we'll mate it with the Atlas V. The CFT spacecraft, as you can see, is well underway. That spacecraft actually was previously built, and on a subsequent chart, I'll talk about the environmental qualification tests that we did, but it was built, sent it out to El Segundo, went through a series of testing. It's been back. We tore a lot of it out to do some inspections based on the testing that we had been completed, or that was completed. That was all successful, and right now we're repackaging up to support crewed flight test after the uncrewed flight test is completed. So not only hardware build and preparation for flight, but a whole other segment of plan, train, fly. You know, one of the things that we did early on when we looked at establishing the program was trying to take risks out of all the areas of the program. So one of the things that we did was actually contract back with NASA to the flight control team that has performed every domestic human spaceflight program in the history of this country. So we actually have plan, train, fly NASA personnel embedded within our team performing crew training. And right now, for crewed flight test, the team is already 65% done with all of the requirements for crew training. So tremendous amount of progress. So that's plan, train, fly, getting ready to fly, as Steve had in his charts. You know, the other big aspect is making sure you can safely recover, meet all the requirements of recovery. And the team has performed multiple trips out to the desert to look at recovery in both nominal and off-nominal cases. And so they are actually ready. They completed their last training for the uncrewed flight test. Integrated testing, a lot of robust integrated testing that we've done with our configuration and final flight design. And there has been learning across almost every integrated test. Parachute drop tests, all of the tests that we have conducted have been 100% successful from a parachute standpoint. We have completed all the parachute testing required for vehicle certification. Steve mentioned they added some additional tests from a reliability standpoint, but that team has been really successful. And I don't know if Tim's still here, but you know, the balloon drops, which are really unique and we use for the first time in human spaceflight. Tim from Near Space is out here at this conference, but they've been a great partner. Land landing qualification, so we've done land landing and water landing qualification testing. That's been completed. Service module hot fire testing, which we did out at White Sands Test Facility here, the NASA site here. And as you guys know, had an initial issues with some of the engine valves, and on the first go around, redesigned those, pretty minimal redesign on the engine valves, and it was successfully completed round 2 in May, which really cleared the way for us to get into the pad abort test, which we'll go through here in a minute. Structural test article was completed over a year ago. And then the environmental qualification testing that was done on what we call Spacecraft 2, which is the spacecraft targeted for the crewed flight test. So that went through a series of thermovac, acoustic, and EMI, EMC testing successfully completed and behind us. Pad abort test, we'll have a little deep dive into pad abort test here on another slide, but that, as I mentioned yesterday, is scheduled for November 4th. The orbital flight test, as I mentioned, December 17th. Vehicle is near ready. And then obviously looking forward to making sure team and crew are ready first quarter of next year for the crewed flight test. And then getting into the nominal service missions. Really important for us to work our way through development and get into services. So I think, so this is a graphic of what the pad abort test will be. Really interesting, and we'll fire the launch abort engines for about 5 seconds. The design of the pad abort is to get about a mile up and a mile out as quickly as you can. So you're moving pretty fast. Right now, what we'll do is we'll flip it around, as you saw. A forward heat shield comes out, then the drogues will come out. Once we get onto mains, as you see, we use the mains to help us get a good separation between the crew module and the service module. One of the things that we worried about was to make sure we had good separation between the crew module and service module. So those parachutes help us actually pull it away and make sure in low atmosphere you don't have recontact. Once you get weight under chutes, you're just kind of waiting until you get low enough. Base heat shield will drop, and then the airbags will inflate here pretty quickly. So base heat shield goes, landing airbags will go. And then we'll come down and land. So again, November 4th, it's gonna be a really interesting 90 seconds. Okay, I'll move quickly. So, moving on, right? So NASA, absolutely fantastic partner. Obviously, they're the foundation of this program. So the focus is really getting into and through the development and getting into nominal servicing missions, and then expanding the market, obviously. And so we're already We're already talking to people to fly additional passengers up to the ISS, want to sponsor additional missions to the ISS, and then ultimately, and hopefully in the near future, the real target is to get additional low Earth orbit destinations. We really are a service vehicle, a taxi, if you will, and so additional destinations are really going to be what helps this market expand. So anyway, try to go at pace to get through. Over to you, Wayne.
Are you ready for questions?
Steve
Because
is.
This crowd has a few questions. And the first one's for Steve. There's been an 8-year gap in U.S. human space flight launches from American soil. Would it have been shorter if you had funded one instead of two providers?
An interesting question. So, Wayne, I don't really think it would have been any shorter with when we let the contracts. If you just think about, we let these two contracts back in September of 2014. So if I look at where both Boeing and SpaceX is relative to this development cycle, both of them have done an incredible job. I think we've learned a lot along the way. We've learned about parachute testing. If I just look at our history, the last 30 years, I spent a lot of time on my career, as did John and Wayne, working Space Shuttle. So, we had a lot of 30 years of landing vehicles on runways. We're kind of going back to parachutes. So that has been something that I would say both NASA and industry has had to relearn. And then the launch abort systems have been a big challenge. We, in this country, have never had systems quite like this, where you use a common propulsion system for orbit and also the launch escape with a pusher. And we've worked through that. So I don't, if I look at the progress of both Boeing and SpaceX, I don't think we would have gone any faster had we have selected just a single company.
Good. This one, we'll alternate. This one's for John. What happens between the orbital flight test and the crew flight test? What type of data will you be reviewing?
So the real focus is going to be, as you mentioned, reviewing the data. So we have a process already laid out, very similar to what we did in the shuttle program after every mission, where every team will plow through their data. They'll come present any anomalies that they had with the data. And then we'll be working through the final certification, the COFR paperwork that we need to for crewed flight tests, and we'll do for every mission.
Good. So this is a kind of an open-ended question. I think you could go a lot of ways with this. What has been the hardest part of commercial crew? The hardest part?
I'll start, maybe John can add in. So, I talked about the technical issues with I would say, parachutes and both Boeing and SpaceX's launch abort systems. I think that's been a technical challenge. I think for NASA, the challenge has been twofold. Managing this firm fixed price contract. It's a different relationship between the contractor and the government. We have turned over much more of the design to industry, which I think is a really good thing. We've seen a lot of innovation from both Boeing and SpaceX. So that part, how we manage the contract and that relationship's a little different. And then just working for us in the government and NASA with a fairly small team. Space Shuttle program had a very sizable team working that program. The ISS program has a fairly sizable team. We have a relatively small team by design. We have a lot of excellent people have lots of experience in human spaceflight from both ISS and Shuttle, but having that small team and working through 2 vehicles, 2 launch pads, 2 ground systems, 2 launch vehicles at the same time. For me, it's something I haven't done in my career, having 2 different systems. And so I think that's been a bit of a challenge on the NASA side, and I'll let John talk about it from his perspective.
Yeah, I mean, first I'd say that it's been a fantastic program to work on. So, I mean, all development programs are hard, so we've had our nominal share of learning, but that's why we set up a really robust integrated test plan. Firm fixed price development programs are always hard. They add additional complexity, additional scrutiny. Working through the technical issues, I don't think is hard. I think one of the constructs that the teams are still working through and will continue to work through as both providers get to and through the crewed flight test is the interaction with not necessarily the NASA program office, but the NASA engineering and the other technical authorities whose experience has largely been based on shuttle and station and the rigor that the NASA community has gone through as they prepare for those. And even though the model is different, in a lot of cases, the expectation of the NASA involvement in the scrutiny is still the same. And so we continue to work through that. I mean, obviously we have great relationships and we will, but that adds a little complexity to the equation.
Well, the number one trending question here is Jim Bridenstine visits with SpaceX today, presumably to discuss commercial crew. What do you expect will come of that meeting? I'm going to short stop that. That meeting's over. If you haven't been following Twitter, then you missed it. But basically, they came away with happy words, and I'll let you read the news on that later.
I can address a little bit too if you want, Wayne. I mean, Jim was planning to go out to SpaceX. He'd been planning to have that visit for a long time, and he went out. He hadn't been to Hawthorne since he's been an administrator, so he went out to talk to Elon and SpaceX and the entire team and see the operation. He saw some crew training. He saw how they build vehicles. I think he's got a visit planned at a later time to come see Boeing as well. So.
Okay. Let's see. Is Boeing using engineers from their commercial aircraft operation on the CST-100?
Yeah, that's been one of the real benefits when we first established the program team. I wanted to bring in significant experience from Boeing on both shuttle and station, because we obviously had those two programs. But I also wanted to bring in personnel from the satellite programs, X-37B, other fixed price development programs. So it was important for me to retain that human spaceflight heritage, but also bring in a lot of newer development expertise and more recent development expertise. We had, from the very beginning of the program, teams from commercial airplanes, fixed wing, and the rotorcraft that came down that helped us lay out the production system, helped us incorporate some of the latest in our digital design infrastructure. So fully embedded from the very beginning.
Good. Okay, John, I'm going to pass this one to you. It's kind of a hot potato. Elon Musk said this afternoon, somebody was not paying attention. They were watching Twitter instead of watching the sessions here. Elon Musk said this afternoon that SpaceX will share its commercial crew, test data, and other intellectual property with others. Will Boeing do the same?
You know, one thing that I think is really important, and we haven't had enough of that in the commercial crew construct because of the ongoing competition, is shared learning. And I think, especially when you get into areas that are going to potentially affect human life and crewed life, I think we have to. And one tough, it wasn't really a tough problem. It was really not a tough problem, but some of the providers that were doing cleaning on some of our tubing weren't adequately cleaning it and inspecting it. And so we found, as we were assembling the spacecraft, that we had contamination in some of our propellant system feed lines. And so obviously we took those off, we re-cleaned them. But then we were reaching back at the cleaning houses that were doing it, and I found out that one of them actually was cleaning SpaceX tubing also. And so I called up Benji, called up Steve, and let him know. But I think, you know, there is a competition. It's important to have competition. I think that makes us all better. But when we get into problems that could affect life, then that goes beyond competition, and you do need to share. And we would do that.
Good. Here's a question that I think has been around for a long time, but a lot of people seem to be interested in it. So I'll ask, and Steve, I think you got the ball on this one. Please define commercial when it comes to commercial crew.
Yeah. So for NASA, the idea of commercial means that the government does not own the intellectual property. The government does not own the vehicles. In the past, you know, we would contract for a vehicle with a given contractor. They would transition that vehicle over to the government. In this case, commercial really is, in Boeing's case, John owns the vehicles, they're his. We are buying a service from him, and that service is to deliver our crews and cargo to the space station, to keep the vehicle there as a lifeboat, and then return the crew. And so in this construct, it's different in terms of ownership. And in previous programs, the government had all the risks. The government did all the financing. I would say in this program, that is different. This commercial endeavor, both Boeing and SpaceX have skin in the game in terms of their vehicles and their resources.
Again, we're not going to be able to get to all the questions, but we got time. This is the last question, and I think it's a very interesting one. Is there a potential for the commercial crew vehicles to service the gateway?
I'll take that one. That's not being fair for John. Yeah, the commercial crew vehicles, we gave both Boeing and SpaceX requirements to go to the space station altitude. So from what I know about the Gateway program, without significant modifications, the Starliner and the Dragon would have difficulty getting to that gateway. So right now, NASA doesn't have any plans to utilize those vehicles. They were designed for a specific mission. So.
Okay. Well, thank you guys very much. You've been a great closing panel, and let's give them a round of applause for their participation. Thank you.